So is there anything we need to say about Archer 2 and praise and thank them for funding this, apart from a simple thank you?
No, well, just yes, thank you for joining, and just to let you know, I think, but this was in the email that we abide by the Archer 2 code of conduct.
So everyone be nice, please.
Yes, that's it. I hope that yeah, you enjoy the course, and I'll be around in case that yes, you need have any questions or you need any help.
Lovely, thanks, Juan. So just to sort of get going, maybe give people an overview of what you all have done before with regards to computers and programming. I was just put a poll up, so I can see only about half of you attending have answered the poll about what's your main programming language that you've used to date. So if people could fill that in, that would be lovely. So while I do that, I'll just sort of introduce myself. My name's Rupert Nash, or just Roop. I'm a research fellow at EPCC. I've been doing computers and science since about 2005, where I sort of started off doing mainly C, Fortran, Python programming during my PhD. And then around about 2010, I started using C++ seriously, and it's been my main language for implementing science stuff since then, with still a bit of Python put in, but yeah, I guess I've got about a decade of experience of using C++ on a sort of day-to-day basis, and I've been teaching it a brief introduction to the language as part of the MSc that we run here at EPCC, as well as doing these courses previously for Archer, now for Archer 2. Yeah, so I see that about half of you are mainly Python programmers, with a bit of Fortran, a bit of C, no R or Java. If anyone wants to admit to being a programmer in a language I've not put on that list, I just picked the ones that are most commonly encountered in sort of the HPC, scientific computing world there. That would be great. Yeah, I did consider putting Julia in, but I guessed that more people would be doing R than Julia, so I was wrong there. Great, thanks, Devasish. Yeah, so I just want to say that sort of during the course, please feel very free to put questions in the chat, or that's probably the best way rather than turning on your mic, because sometimes that might get lost. So you can, there's a raise hand button as well if you want to ask a question, put questions in the chat. You can put your voice on if you want. I'm very happy for you to do that as well. Being interrupted where I've made something not clear enough or something is great, means that, because if you're not sure of what I'm talking about, probably there's at least one other person, maybe even all of you, don't know what I mean. So getting that cleared up as soon as possible would be great. Yeah, I'm going to close that poll now. So another poll question I wanted to ask was, have you done any C++ before beyond Hello World? Okay, so about half of you seem to have done some C++. Many more of you. So I'm afraid that today is probably going to be a little bit teaching your granny to suck eggs, then if you've done some non-trivial C++. So apologies for that, but I saw that some of you, this course is really going from you know how to program in a language that's not C++ up to, well, you can do something and you have at least the tools to do something more interesting. So, yeah, what I'm assuming with this material is that you're a good programmer in some other language, whether that's Python, which seems to be the most common, or C, or Fortran, or Julia. But this is not an introduction to programming course. I'm also assuming that you're basically competent finding a way around the shell. You know how to change directory, list things, remove files, run a make file, and so on, and that you have access to a terminal with a C++ compiler. So regarding that, we have set up an Archer allocation for you, and I've approved accounts for many of you already. I don't know if I've got everyone. So you can connect to Archer much as you would any other HPC system. SSH your username at Archer. I have no issue at all with you using your own system, but if you have any technical problems, I can't help you. And in particular, if you are using a Windows system, I'm afraid I've not used Windows since the 90s, so I literally have no idea what I'm talking about with regard to that, except, you know, it's a computer. So on your system, you might want to take a clone of the repository, which contains all of this material. I have heard of Putty, yes. It's an SSH-like client. I'm sorry, I know nothing. I know nothing. Sorry, what do you mean, Fabio, by hints? So Christoph, yeah, Killian's right. I was about to say, what Killian said is correct. If you set the permissions on your key. So Christoph, you've done something wrong with your keys. You usually have to load the private part of your key rather than the public part. I think it may be that you're trying to load your public key as your private key. These are two separate files. One is secret and you've got to be careful with. The other one is your public key, which you can give out quite happily. When you first log into Archer 2, you'll be required to change your password from the password that was set in the safe to one that you and only you know. Yeah, so everything is linked to from the C++, or from the course page on the Archer 2 website. You go to training, the C++ page. If you go to the course materials, it's all there. And oh, for some reason that's not highlighting as a link. So you've got the pages view here and then the actual repository view here. It's just a C++, sorry, a GitHub repository page here. And let's see. Right, I'll switch back to my slides. So we don't need you to have a C++ compiler right now. So perhaps if you, Juan could answer any connecting to Archer 2 problems while I get going on the material. If that's all right. So thank you, Juan, that's brilliant. So another thing is to say this course isn't mainly about writing efficient software, because the biggest thing that you need to do that well is to understand your problem and choose the right sort of algorithmic approaches. And here we're going to try and think about a slightly lower level approach, sort of from the bottom up, and how you might implement some of the patterns that you have come up with in an efficient way using C++. And we run courses on this at EPCC as part of the MSc, and I believe we occasionally do it through Archer 2 and Prace training. The course you might be interested in there is called Parallel Design Patterns, and it's really an excellent piece of training. So I'm focusing on sort of scientific technical computing, and for all this sort of field, when you actually come down to running a program, what it's all about is getting a large amount of data from your memory, the RAM that's in your computer, your server, or your laptop, or whatever it is, getting that from the main memory into a core, doing something useful to it, and then storing it again. And this is why Fortran is still very much alive and relevant, you know, underpinning all of the big Python like NumPy and TensorFlow, well, maybe not TensorFlow, but NumPy, SciPy, various bits of machine learning stuff all have Fortran deep under the hood somewhere. But the problem with Fortran is that it forces you to confront the fact that you are dealing with a rectangular or cube or hypercube of numbers at all points. And C++ is really more about building abstractions and composing them in a way that maybe makes more logical sense from the point of view of your sort of abstract program, rather than this is my array of numbers and I have to scale everything by whatever here. So I'm going to have various little rules of thumb highlighted in these slides. And, you know, we could talk about C++, do a whole master's level course on it. So this is just 4 half days. So I've really just picked the handful of features that you really need to understand in order to write a more modern style C++, focusing on the sort of HPC technical computing world. And I'm really not trying to teach the whole language in all the different styles that people have developed over the last 30 years. And again, please ask me any questions you've got whenever. So C++ has a bit of a reputation in sort of programming circles. So it's a very big thing. It's now come up to just over 1,800 pages for the latest revision of the standard. It's got lots of different parts. It's got the sort of C underpinning, classes, generic programming, functional programming, exceptions, the huge library. Now modules have come along. It's got asynchronous coroutines now. And for these reasons, it's a little bit encourages caution in people who are perhaps not familiar with it. So Bjarne Strustrup, who's the person who created the original C++, said that C makes it very easy to shoot yourself in the foot. C++ makes it harder, but when you do, it takes your whole leg off. Which, yeah, you can sometimes get pretty serious problems if you make a mistake. And And it's also quite sort of expert friendly, which I do have to admit is a fair criticism of the language. Another thing is people say C++ is like an octopus made by nailing legs onto a dog. So the joke is, why is it called C++ 20 now? Because that's how many legs they had to nail on to fix the octopus. But, you know, the point is that you don't have to use all those hundreds of different multi-tools for every program or every function in a program. You can use the parts that are appropriate for your program in that situation. Sort of the philosophy of the language and the wider community that goes around is it's trying to be a general purpose language. It's trying to be able to do most things well. Maybe not everything, but most things. And it's aiming to be very flexible by letting you, the developer, build the abstractions that you need, as well as providing a large number of these abstractions through its standard library. And these abstractions also form a useful vocabulary for talking about your program and what it's going to do. And this is for both for yourself, for your own use, and to be able to talk about your code with other developers, whether this is just your small team working on your in-house code or if you're contributing to something bigger. One of the key focuses of C++ is on performance and efficiency, and this is always targeted when in the language. It has a philosophy of either zero overhead or you only pay for what you use. And there's really only a handful of features in the language that impose a cost on you, whether or not you use them. So the sort of more philosophical things are to use the type system to express what you mean. Okay, not what the computer should actually do, but express what you mean because you're trying to communicate with the reader, not the compiler. And whether that reader is, the rest of your team, some randoms on GitHub, or yourself next year when you have to rerun some simulations to keep reviewer number 3 happy. It's also worth pointing out that C++ is alive. It's a work in progress. Every 3 years, the standardization body is releasing a new update, and the latest one, which is called C++ 20, because it was finalized. I think it was actually in January this year. It's still not fully implemented by any compiler. It's got various new features, and the next one that's going to come along in about 2 years now is really just getting fully underway. I think COVID has slowed down progress, which is perhaps a good thing from the language's point of view. The thing I'm most looking forward to is a sort of a consolidation of all the new C++ 20 features, because it's still not clear what the best way to use them is. So here's a few references. Bjarne Stroustrup has an introduction to programming book using C++. It takes you from you know nothing to you're an expert C++ programmer, well, give or take. It's very long, it's widely respected. A better book is, for many of us, would be the second one here, the Tour of C++. This assumes that you're an experienced programmer, but you don't know C++. And it got an update for C++ 17 a few years ago. So for sort of references, so when you need to look something up, when you're like, I'm sure there's a function that does that, or there's a class that does this, what arguments does its constructor need? By far the best is CPP reference. If I'm programming actively, I have this open. You can see a lot of these things are colored in the I've been clicking on that color thing. So it's got everything pretty much explained there. It's a bit heavy on jargon, but it is very good and well organized. There's another book by Scott Myers, which is called Effective Modern C++. It's based on the 14 revision of the language, and this is generally considered to be the next book to use. Stack Overflow is always available, but unfortunately there are a lot of idiots answering questions on there. So that can be a problem, trying to filter it out. So as is traditional for any new language you encounter, we have to do hello world. So here it is in all its glory for C++. And if you're on the command line, you could type that into yourself and then compile it. So what we're doing here is we're invoking the compiler. In this case, this is the GNU C++ compiler, G++. I'm specifying which standard of the language I'm using. So I believe that GCC now assumes the default to be 17, starting from either version 10 or 11. I think it's 11. So commonly you will want to be specifying which standard version you are aiming at to your compiler. Anything earlier than 11 is irrelevant as far as I'm concerned. Then you specify your source file, which is the which file contains the test of your program, and then the -o option says place the output executable in the thing that follows, which I'm just going to call hello for the executable. And then I can execute this, and it does indeed print hello world. So let's do what's happening here in a bit more detail. Source file, the first thing it does is it runs it through this, what's called the preprocessor, which works at a sort of a textual level. It doesn't understand most of the language, but it processes these things called directives, which usually start with a hash and then are followed by something else. And the hash include directive basically takes the contents of another file and it pastes it into the current compilation unit or translation unit. The angle brackets, the less than, greater than signs, say to the preprocessor to look only in system directories. And then the name of it is iostream, which is one of the standard library headers that's included. So when you're creating a program, every program must have exactly one function called main, and the signature that it has various variants. The most common one is that it returns an integer and it accepts two arguments, the first of which being an integer and the other one being an array of strings. And the compiler and the operating system arrange for this function to be called immediately after your program starts. I've not shown it here, but you can also get the command line arguments. That's what I was mentioning before. So this std thing is normally pronounced stud, and it's the standard library namespace. So a namespace is a little bit like a folder in a file system in that it allows the scoping of names. So you could have a local variable called cout, and this would not interfere with the standard, the stud cout, because they would be in different namespaces. And then we can use what's called the scope resolution operator, this double colon syntax that lets us access something from inside a namespace. This is much like a slash in a file, a path separator. And the cout variable represents console output. So basically this is standard output or std out. And for reasons, the standard library uses what is more normally, especially to C programmers, considered the bitwise left shift operator to mean stream insertion. And what this means is take the thing on the right-hand side and output it using the thing on the left. And then return an updated outputty stream object as the value. Can I elaborate on reasons? No, not offhand. I'm sure the internet can tell you. There's a book called The Design and Evolution of C++ that's been locked in my office in the base building for a while. I think basically they thought it looks like piping something into the thing on the left. I think it's meant to be just a visual representation of output or stream insertion. It is perhaps not the wisest choice, but it is what it is. It is stuck for sort of social rather than technical reasons. So what this line does is it takes the cout object and then it outputs the string hello world, and then that expression returns a new or the same possibly output object, which is then used to output this std end line thing, which is basically a cross-platform way of saying /n for Unix people, or /r/n, or whichever way around it is for Windows. And this also ensures that the file flushes its output when you use std end line. Then every statement in C++ must finish with a semicolon. So as you get used to the language, you will have to get used to making sure you stick your semicolons in. Python programmers, this will catch you out a little bit until you get used to it. And the language treats all white space exactly the same, as long as it's not inside quotes, obviously. So spaces, tabs, line breaks, they all count. They all are equivalent. Any number of those is equivalent to a single space, as far as the language is concerned. Okay, so let's have a go at this. So you could use your laptop, you could use Archer 2, and once you're in, you need to load a compiler. I'm sorry, I forgot to update this for Archer 2. The module you need to load is GCC 10, but you can just type module load GCC, like here. So if anyone's still having problems getting connected, could you please say something in the chat and we'll try and help you. Okay. So yeah, like I said, you can get the slides and the exercises all here. And once you're in, you can change into the directory that contains it. So let me stop sharing that and I'll just share my whole screen. I have shared the slides with you. The slides are all here. The link is earlier in the chat at 10:40. Sorry, 9:40. Let's make that a little bigger. So you can look at your the source code, which is the same as before, and you should be able to just compile this. Oh, my terminal has gone very weird. So in the sort of standard way of Unix tools, no output means success. So you can then run it by just typing the executable name. And yeah, so if people want to raise their hand when they've run this successfully, either on Archer or their local machine. Fabio, like I said, I forgot to update the modules for Archer 2. Just module load GCC will be fine, like as I've highlighted here. Yeah, for these things, any of the GCCs will be fine. We're not doing anything super up to date. Anything newer than about GCC 7 should be fine. Maybe even 6, yeah. Something has gone wrong with my terminal. I'm going to have a new one. So those of you who've not raised your hands, is there anything blocking you? Happy to answer questions via chat or whatever. Well, I think if you don't load a module, Fabio, I think the system provided one, maybe version 7 point something. That'd probably be about right. Yeah, so this is the system one. This means you've not loaded a module. So if I module load GCC, you can see it switched to a different executable. Right. So people who are still having issues, is there anything I can do to help? Yes, I'm sure the binary size will change a little. Okay, so I think maybe some people have forgotten to raise their hands, so if there's no one having problems. So I'm going to carry on. If you, can I just lower everyone's hand for you? Is there a button to do that? I think so. Great, so thanks everyone, well done. Let's carry on with this. So, take over the screen again. Okay, so a few things that, you know, it may be clear, but I want to make sure everyone understands is that C++ is a typed language and every variable must be declared to the compiler. one proviso. This is, you can often tell the compiler to figure out what the type is for you, and that it counts from 0, much like C in Python, but not from 1 like Fortran or Julia or R or something. So a variable, this is one of the sort of key parts of the language. So a variable is an object or a reference that is declared, like I said before, to have a name, a type, and a name. So the type you can sometimes tell the compiler to figure out for you, but that still counts as a declaration. And so what's an object? An object is a region of storage, a little bit of memory inside the sort of abstract C++ machine that the language works with. And this is a region of storage that has various properties like type, we just mentioned, size, it has a value associated with it, and it has what's called a lifetime. It comes into being at some point during the execution of your program, and it is released later. So type. So type is a property of an object or also an expression which restricts the operations that are permitted on it, as well as providing some semantic meaning to the otherwise generic sequences of bits. So applying a type to a bit of memory actually restricts what you can do to it. However, it allows you, the programmer, to reason about it and to distinguish that bit of memory from this one over here and treat them differently in some way. So can be quite useful. So the language includes various fundamental types, a very brief summary of which is in this table. So there's a void type, which means nothing. It is used to indicate a function that returns value or the absence of a value. As far as I can tell, I am sharing my screen. I have a slide up called Fundamental Types. Several people can see it, so I'm sorry, Mohammed, if there's a technical problem. With these cloud things, there's nothing I can do. Okay, great, good. Coming back, good. There's a bool type, which means Boolean, as in a true or false value, and true and false are the ways you spell the true and false values, obviously. Notice both of these are lowercase, unlike Python, where they'd be capitalized. Then there's the int type, which is a standard signed integer. And this is going to be a signed type that is fast for your machine. Unfortunately, the size of this is not specified. It's guaranteed to be at least 16 bits. It is usually 32 bits on many machines. It could be 64 bits. It depends. You have to figure this out. So unfortunately, int is not always the best choice to use, despite it being the sort of language's default type to use, because you do not know what size it is. Yes, they're on GitHub at the link that's being sent round. Then there's the type called double, which is a double precision floating point value. And this is usually, but not guaranteed to be, but really, thank you, Christoph. This is an IEEE whatever number, 64-bit floating point number. And this is sort of the default size you would use to represent a real number in sort of scientific computing domains. And then there's a stud byte, which represents raw untyped memory. This is the sort of thing that you might use to load a block of data from disk before you do something to it, or to send a bunch of stuff over the network to some other machine. There's also unsigned versions of the integer type, which you can get by just putting the keyword unsigned in front of the type. And perhaps more usefully, the header C studint, which is one of the standard ones, provides fixed width integer types that are available on your platform. You could have, for example, a signed integer which is guaranteed to be exactly 32 bits wide, and here's an unsigned one that is 64 bits wide. And being able to guarantee the size of these things is often quite helpful when you come down to it. So another fundamental type another type that you use often is a string, which is just a sequence of characters that represent some text. Unfortunately, they're not Unicode strings like you might get in Python 3. They are just a sequence of text characters in something. So if you want to use this class, which is provided by the standard library, you need to include the string header file, which contains all the information the compiler needs to let you use it. So, for example, if we were going to alter the hello world from before, we'd have to include iostream and the string headers. And then we could say that we're going to have a stud string. We're going to call the variable message, and we're going to assign it an initial value of hello world. So to give a string, you just put it in double quotes. If you use single quotes, that means only a single character. This is a different type from a double quote string. So this might catch out Python programmers. But then all you Python programmers are using black, right, to enforce double quotage anyway. And then you can use this string as before. You can output it to the console quite happily. Okay, so we've done a super light overview of what a variable is. So let's talk about a function. So what a function does is it takes a piece of code. You take a piece of code and you put it between the braces, so the curly brackets, like this or this, and it gives it a name. And this allows you to take that piece of code and use it again later. So we can create a function, say hello. It takes no arguments and it returns nothing. And what it does is it outputs the string hello world to console out. And then later on, you can invoke this function by name. You give the name, you place any arguments it requires inside the round brackets, and these round brackets invoke the thing or call it. So when you've got a function, you must declare what the return type is and what the parameter types are. And parameters are basically just local variables. So they are variables that exist only within the scope of the function that get initialized when you invoke it by the caller. And inside the function body, you can return a value to the code outside by using the return statement. So here, and the type of the expression that you give to return must be the same as, or at least convertible to, the declared return type here. So if we have a function that simply adds two integers together, let's call it sum, we know that it takes an integer and another integer, and we're giving these names A and B, and this is going to return an int. And then inside the body, we have some suitable code to actually make that happen. You can also use what's called a trailing return type here. So you put the word auto in front, which basically says to the compiler, you're going to figure this out from something that comes later. We have the function name and parameters as usual. And then we have the arrow syntax and saying what does it give back, and it's an integer. So these two definitions are exactly the same here. Yeah, so like I said before, to use a function, you call it, you give its name and provide the arguments inside round parentheses. So to use this one before, we can create a variable x, give it a value, we can compute the sum of x and the number 100, and then output that to the console. and the parameters of the function must match at least one declaration that exists. I say one declaration that exists is because one of the fundamental things C++ has is function overloading. So you can create multiple functions which have the same name but different arguments. So in this little block of code, I've got two sum functions, one taking two integers, excuse me, and one taking two doubles. And when you give the name sum, when you call it, the compiler knows the type of the arguments that it's being invoked with, and it will try to find the best match from all the candidates with that name. And the compiler will also try to use any built-in conversion rules or any rules that have been defined by the programmer, by your types. So let's do a few little examples and think about what happens. We've got integers I, doubles D, an unsigned U, and strings name and file. Oops, sorry. So if we call sum with the two integers, that's going to be an exact match for the 2int example we had on the last slide. Then here, when we have literal 3s and a literal 72, the language basically says a literal number with no extra stuff on it is an int. So you just have to know some of these rules. So this is also going to call the int overload. Now if we use an int and the unsigned, does anyone want to hazard a guess as to what will happen? Exception, okay. Yes, Killian, I was about to call you out and say it's definitely not an exception. This course is going to avoid exceptions entirely, except for one very minor point. Because if you're doing HPC, if you throw an exception, your performance has just gone out the window. So, well, who cares? Yes, so Christoph and Matthew are correct. This is going to promote the unsigned value to a signed integer type. So the language has some various rules about these integer conversions, which basically say you can turn an unsigned value into a signed one, and you can turn an integer into a floating point number for you. So if we call sum with two doubles, that's going to be fine. Again, the language says a literal floating point number, whether that's expressed in scientific notation, like I've done here, or if you go 1.0 or whatever to express a decimal number, that is a double. The type of that literal is a double. So again, that is going to call the double. Much like I hinted at before, if you call a double and an integer, the integer will promote to a double. Any guesses for this last one with the sum of name and file? Yeah, so Matthew says error. Yes, it's correct, because we've not defined, we haven't given a declaration of sum that takes two strings. Yeah, so this will happen at compile time. All the type checking and stuff happens when you compile your program. If you want to have an error at runtime, you have to sort of do this yourself by some mechanism, either throwing an exception or dealing with error codes and such. So C++ says that operators are functions. And so for the sort of non-fundamental types, these are just functions with odd names. So for example, to make that last one that was an error work, we could define this operator overload. So it's operator plus is spelled, so it's fairly clear what the names of the different ones should be. So minus would be operator minus and so on. Mohammed asked about the implicit conversions. Yeah, CPP reference. There we go. Implicit conversions is the term it uses. So there's a big long list of them. I apologize for the language's lengthiness. You rarely need to know the details, but unfortunately the language has a love of turning everything into an int or a double is good enough. And you just need to think carefully sometimes about what is going on if you have this. Let's go back to the slides. So to make the string addition work, we need to define a function with the name operator plus, and we need to say what the type size is going to be, a string A and a string B. Let's not worry too much about the extra bits there for the moment, but this is the canonical way to define this here. And we need to say that it returns a string because, for example, you could just have it concatenate the two things. And then you can use the natural syntax when manipulating these in another bit of code. So we've got a string, which is the username, Alice, and we're adding .csv to get some data file for this. So here you have probably the first use of auto here. And what auto means here is, to the compiler, is figure out the type of this for me. And what it will use to do that is the expression on the right-hand side of the equals sign, basically. So this means that you can't have an uninitialized variable if you're using auto, which is one of the pros of doing this. And there's, in fact, the name of a pattern, which is almost always auto, suggesting that by default you should be using auto for your variable name to declare your variables, and only not to do that in unusual circumstances. Lots of questions. So auto does have to be deduced at compile time. So anything involving types basically has to happen at compile time. Yes, so I'll answer Christoph first. Data file will be typed std string 2. Yes, almost certainly. So in this case, if we're using this operator plus, it will go, okay, I'm getting a standard string as A, and I'm getting a string literal B. A string literal will implicitly convert to a standard string, and then it will call this, which will return a std string. So basically, the compiler works from inside out of your function call. If you've got a function call on the right, it will go inside out. It will match do the type inference step by step until it knows what the type of this whole expression is, which will be a string. And then it can use that to say, okay, data file is going to be a string. Marcelo is asking about the const thing. We'll talk about const later on. It's not really to allow compiler optimization. It's to allow you to pass in it's because you're expressing the meaning of what's happening here. Why should concatenating two strings modify one of them or both of them. There's no logical reason for that to happen, so therefore you should qualify it with const. Unfortunately, it would have been quite nice if the language was const by default and you had to, for example, say mutable if you wanted not to. And indeed, Rust, for example, takes that approach. But because C++ wants to interoperate with C, unfortunately, that's not possible. So you end up having to write const a great deal. Okay, and we'll talk more about these things later. So let's try and write some code. So what I'd like you to try and do while I go and get a cup of coffee is change this bit of code to accept the name it read from the terminal, create a new message saying hello, comma, your name, and print it to standard output. So in the main function, I've got code that will read a string from standard input, from console input, and then it will call your say hello function. So if you could all have a go at that, and then we'll stop. In fact, why don't you all either take a break now or have a go and then take your break, and we'll reconvene at 11 o'clock. Perhaps. So I will take, you could get this from the slides yourself, but to make life a little easier, I will put it in the course chat pad here for you. Here you go. It's from the course webpage. This one. On the Archer 2 website, if you just go to training, upcoming C++, course chat.